Protocol buffers is an extensible mechanism developed by Google for serializing structured data. It is especially useful for developing applications or services that need to communicate with each other or simply for data storage. Google uses protocol buffers to store and transfer structured data within its platform. Protocol buffers allow us to serialize our structured data in a very compact binary format. It also allows to deserialize this binary format to recover the data in the original format. Protocol buffers is cross-platform and is independent of the programming language that we use to develop. Think in a traditional format like XML or JSON, but smaller, faster, and simpler. In order to specify the data structure to be serialized, a message description language is provided by protocol buffers. This specification is saved in files with the extension proto. Proto files are compiled with proto-C, which is the protocol buffers compiler. Compilation generates the necessary code to serialize and deserialize messages. The compiler can generate the source code in the programming language of our interest. The provided programming language interoperability allows us to develop highly decoupled services that need performant data exchange, even if those services are developed using different technologies. Protocol buffers was designed prioritizing simplicity and performance. It was originally developed to be lighter and faster than the traditional XML format, so it is ideal to be used in services and applications that require high performance. Distributed systems, queues of messages, real-time applications, Internet of Things, etc. In this extensive tutorial, we will use protocol buffers with the C++, PHP and Rust languages. We will create a JSON file containing an object with information and logo of a company. We will define and compile the data structure with the protocol buffers compiler. From the data of the JSON object, we will create and serialize a proto buffer that will be stored in a binary file using C++. At last, we will deserialize the proto buffer using the code generated by the compiler in C++, PHP and Rust. The main goal of this tutorial is to understand how protocol buffers works and how we can use them in our applications written in C++, PHP and Rust. I hope you find it useful. First of all, we will download and install the protocol buffers compiler. Using the web browser, we visit the GitHub repository at github.com/google/protobuf. In the releases section, we will look for the latest available version and then copy the tarball URL. The current version is the 3.11.4. Download and unzip the file. Next, compile the source code and install the protocol buffers compiler. We can check that it has been installed properly by running the command proto --version. We start by creating the project folder that we will name protocolbuffers_demo. In the root of the project, we create the proto3 subfolder where we will put the files with the proto extension. We launch our ID or favorite source code editor and then import the project. Now we specify the data structure we want to serialize by defining a message type in a file with the proto extension. In this tutorial, we will create a very simple example of a proto file with the definition of the company message. Inside the proto3 folder, we create the company.proto file. This will be the protocol buffer that we will use in this tutorial. Within the company message, we also define the enumerated type company category with different company categories. The company message have the fields ID, name, description, category, employees, active, logo, and created. The field name logo will contain the logo of the company in JPEG format, and the field name created will contain the timestamp of the data when the company was created. As you can see, this message is quite simple, although with protocol buffers we can define much more complex data structures. Once the message is defined, we will run the protocol buffer compiler to generate the source code in C++, PHP, and Rust in order to serialize and deserialize messages of type company. In this tutorial, we will make some implementations in C++, PHP, and Rust, so we will create a specific folder for each one of them. Inside each of these folders, we will create the proto subfolder, where we will put the source code generated by the protocol buffer compiler. The protocol buffers compiler allows you to compile a proto file in the programming language of your interest. It means if we want to generate the corresponding source code in PHP, we must indicate to the compiler that we want the generated code to be PHP. The compiler uses two arguments. The first argument indicates the programming language and the destination folder of the source code to be generated. The second parameter indicates the proto file we want to compile. We place the generated source codes in the respective proto subfolders we previously created. Now we have a look at the source code generated in the PHP language. We continue with the generation of the source code in C++, following the same procedure we did for the PHP language. Now we have a look at the source code generated in the C++ language. Unfortunately, the protocol buffers compiler currently is not able to generate code directly in Rust. However, the compiler has an option to indicate what guidelines must follow in order to generate source code in other programming languages. There is a library written in Rust that provides a function to run the protocol buffers compiler to generate code in Rust. Next, we will implement an application in Rust that allows us to compile protocol buffers to generate the code in Rust. Now we create the subfolder protocols-rust-cli inside the source/rust folder. Next, we create the file cargo.toml, where we will define the manifest of the package to implement. Apart from the name and version of the package, we also indicate the dependency needed. Rust is a high-level programming language that lets you make software with a performance similar to software made in low-level languages such as C or C++. The main feature of Rust is the way the memory is managed, so the lifecycle of any variable or memory location in our program must be clearly defined and must follow specific guidelines that guarantee a safe usage in runtime. That is why the programs made in Rust don't need a garbage collector. Now let's start to implement the package protoc-rust-cli in the main.rs file. I would like to point out that despite having the experience of having developed some applications in Rust, I am still too far off mastering this programming language. That is why during this implementation in Rust, you will see compilation errors and some bug fixes. I strongly encourage you to first read a specialized book and practice a lot if you want to learn Rust in depth. Once we finish the implementation of our protocol buffers compiler for Rust, we will proceed to generate the source code. Now we'll have a look at the source code generated in Rust. The next thing to do is to create a simple makefile to easily compile the company.proto file in the three programming languages. If in the future the structure of the company message needs an update, we can easily recompile it in just one step. Now it's time to save all the changes we made so far. We initialize the Git repository locally, create the git ignore file, and make the first commit. Now that we have compiled our protocol buffer, we will begin with a practical exercise to learn how to serialize and deserialize messages. We will define a JSON object with the data of the company Microsoft and save it in a file. Later, we will implement a program to parse the JSON and serialize its data using a proto buffer that we will save in a binary file. We will appreciate the difference between the size of the JSON file and the proto buffer. Above all, we will observe how easy it is to serialize data using protocol buffers. In the JSON document, we will include the image in JPEG format of the Microsoft logo. This will be possible by encoding the image in base64. Now let's copy and paste the encoded image in the field logo of the JSON document. Now we will implement the C++ program that will get the data from the JSON file and serialize it in a proto buffer. We start by creating the empty file create_protobuffer.cpp and the folder third parties, where we will include all the dependencies we need. To decode the image of the company, we can use any C++ library that handles base64 encodings. I usually use the implementation provided by the developer René Liefnegger, which consists of a single header file and a single implementation file. Clone this repository inside the third parties folder. In order to pass the JSON document, I will use the well-known RapidJSON library. One of the features of RapidJSON is that header files also include the implementation. Clone this repository inside the third parties folder. First, create the makefile to compile the program and its dependencies. And now let's start implementing the program create_protobuffer. We include the headers of the dependencies. The program will be executed from the command line by passing two arguments. The first argument is used to specify the input file that contains the JSON document, and the second argument is used to specify the output file where the serialized protobuffer will be saved. We will load the contents of the JSON file in a memory buffer in the stack. I want to clarify that my priority in this tutorial is to simplify the code as much as possible. Having said that, you should take care of the memory management to avoid segmentation faults or memory leaks. We create a message of type company and fill its fields using the available setters in the code that we have previously generated when compiling the protocol buffer. We will fill the logo field by decoding the image in base64, thus recovering its original binary encoding. Next, we will fill the created field, converting the data string to the Unix timestamp format. Finally, we serialize and save the proto buffer to the output file specified in the program arguments. We compile the program with the command make create underscore protobuffer and fix all the bugs. Once the program has been compiled, we will execute it indicating in the first argument the file containing the JSON with the data of Microsoft, and in the second argument we indicate the file name where we will save the generated protobuffer. If we compare the JSON file with the file containing the protobuffer, we observe a difference in the size of both. Although the reduced size of the protobuffer is the most remarkable feature, it is important to say that the speed of serializing and deserializing protobuffers is far superior compared to that of traditional structured formats. This is ideal to be used in high-performance environments. Before going to the next part of this tutorial, we will make a new commit to save all the changes we made so far. In the previous part of this tutorial, we have implemented the serialization of the data of a company using protocol buffers. In this final part, we will do the opposite. We will deserialize the protobuffer we have generated and save it in a binary file, and then we will show the data on the screen and save the logo in a file. Taking advantage of the fact that we have just implemented the serialization in C++, we will start the first example of deserialization using the same programming language. Let's create the file read_protobuffer.cpp. The program will get through its arguments the file containing the protobuffer with serialized data of a company. We create a message of type company and initialize it by deserializing the protobuffer stored in the specified file. We display the data on the screen using the available getters in the code. Finally, we save the contents of the logo field in a binary file named logo.jpg. Now we will modify the make file in order to compile the program. Compile the program with the command make read_protobuffer. Once the program has been compiled, we will run it, indicating in the first argument the binary file containing the protobuffer of the company we have generated in the previous part of this tutorial. In case of success, it will show on the screen the data of the Microsoft company and the file logo.jpg should have been created. Let's check that the data shown is correct, comparing the displayed values with the values we use in the JSON file. Before going to the implementation in PHP, we will make a new commit to save the latest changes. Now we start with the implementation in PHP to deserialize the protobuffer. We will follow the exact same procedure. However, the implementation in PHP is a bit more tricky. We will have to install and include the dependency google/protobuf. In order to install this dependency, we first install the Composer tool in our computer. Composer is a dependency manager for PHP. Installing Composer on macOS is not trivial, and it requires following the steps I show in the video. Once installed, we make sure that it has been properly installed just by executing the command composer ---- version. The current latest version is 1.10.1. Inside the source/php folder, we will install the dependency by executing the command composer require google/protobuf. Let's start with the implementation by creating the file read_protobuffer.php. As you can see, the code of this program is similar to the code we previously made in C++. PHP is an interpreted programming language. It means we can skip the compilation and run the program with the command php followed by the file read_protobuffer.php and the file name of the protobuffer. We fix the bugs and retry again until it works properly. Finally, we see how the data is shown on the screen and the file logo.jpg is generated. We ensure again that the file logo.jpg has been created properly, opening it with the image previewer. Finally, we continue with the implementation in Rust. Inside the source/Rust folder, we create a subfolder named read-protobuffer, and inside it we define the package read-protobuffer in the file cargo.toml. Let's compile the program with the command cargo build. We fix the errors and retry again until the program compiles. Once the program has been compiled, we will execute it, indicating in the first argument the binary file with the proto buffer generated in the previous part of this tutorial. Finally, we see how the data is also shown on the screen and the file logo.jpg is generated. We ensure again that the file logo.jpg has been created properly, opening it with the image previewer. And finally, to conclude this tutorial, we will make the last commit to save the latest changes in the code.